All right, hey folks, thanks for coming to science class. I apologize for not being here, but my activities this afternoon will hopefully benefit your educational experience. So, to get started, just do a quick little run through on the PowerPoint. Briefly, there is a possibility of a couple of note-taking, as well as a DVD that you'll be watching towards the end of it. So, first things first, let's have you start off by grabbing your puzzles. You're going to need your puzzles because you're going to practice your vocab puzzle real quick. Then we're going to do a C5 worksheet with a little bit of notes. And then there's a great transformation DVD that you'll hopefully get to, and you'll round out the class with that. So, first and foremost, everyone right now, you have 1 minute to get your vocab puzzle out on your desk, scatter the puzzle pieces, and we'll start the timer shortly. Timer's clicking. Go!
I just want to say after.
All right, now everyone should have their puzzle out. For those of you who are not ready, well, we're not going to wait for you forever here. So, get your puzzle out, and we got our stopwatch ready to rock and roll here. Puzzle people, ready, set, begin. Again, trying to get your puzzle pieces organized. As soon as you've got them completed, please look up, check your time. Every time you do this, your time should improve. We're going to go to about the 2.5 to 3 minute mark here. So just sit here and politely, kindly cheer you on. Come on, students. Get your vocab puzzles together. You can do it. Come on. Good job. Keep it up. Come on. This is about where Brendan LaForest finished the other day. He finished in about 34, 35 seconds. All right, we're waiting for somebody else to get done. Good job. Good job. Finish up. So this is the benefit of having looked at your puzzle over the weekends. You get to see who you are and who you aren't. All right, keep going. We're at about almost 50 seconds here, almost a minute. Come on, people. Buddy, you're a big man, I'm never second of bite on a fan and a bite, don't get mud on your face, a big disgrace. Kicking your muzzle all over the place, singing, we will rock you. Ah, chicka, chicka, ah. Come on, people. You're only at 1:20. Let's go. Come on. I'm not going to be here later today. So, keep going. We're at 1:30. Somebody's got to be done in the room by now. Give yourself a round of applause. Good job. Pat yourself on the back. Well done. It's the other students we're worried about now. Come on.
I was doing that in one shop like the whole class we were going. We were like,
Almost 2 minutes here. Keep going. Note the time when you finish. And when you do finish, make sure you mark off on the attempts box. Keep going. We're going to stop at the 2.5 minute mark here.
yeah, Mark. I get it because there's Mark.
Come on, finish strong, people. Just under 2.5 here. All right, I'm going to stop there. If you didn't finish in under 2.5 minutes putting your puzzle together, you need to spend more time practicing this at home. All right, go and mark off if you did get it done. If you got less than half of the puzzle done, bring it home. That's your new homework for tonight. Alrighty, next up. Your homework for tonight's practice your vocabulary puzzle. So obviously you're putting your puzzle away, you're bagging it up. Vocab practice for tonight. Quiz on the vocabulary material will be available starting on Wednesday. All your new C-layer assignments are due this Friday. So you gotta make sure you're working on that in the classroom as best you can. Excuse me. Thank you. Alrighty. This Friday, assignments are due. Don't forget it. Alright, next up. Will everybody in the room, we'll take a minute here and we'll pause the video, but will everybody please take a moment and get the C5 worksheet from over on the side of the classroom over by the cupboards. It's a mullet-looking worksheet. C5, it looks like some area for you to take some notes. That's going to be your C5 assignment. So pause the video. We'll come back after everybody has the C5 worksheet. All right. So let's just assume that everyone now has their paper. The video's just been started. Obviously, for those of you who have taken a look at the screen here, you got a chance to get a sense and see what's going on here. Hold on one moment. I need to pause this. All right. So for those of you who have your C5 worksheet right now, it's kind of a little bit of an intro here. We are going to go over the basics regarding evolution, but to do that, we have to touch on the foundations of genetics. And so the screen here, Adaptations Over Time, with a nice quote from Ian Malcolm, a very important character from the movie Jurassic Park. His statement of life always finding a way is relatively true and consistent with what we've discovered as scientists when addressing adaptations over time, changes over time. Life invariably will find a way to survive. Now, a lot of times this is based upon organisms passing their genetics to their offspring through their DNA. Portions of the DNA are codes that for certain genes and yield certain traits. And generally the DNA is passed on either through mitosis or meiosis. Please remember, mitosis being one cell dividing into two. My two cells, mitosis. If I stub my toe on a table or something like that, I leave behind some skin cells that need to be replaced through mitosis. But my own cells come from mom and dad. So mom and dad cells came together to make my cells, my own cells. So we'll talk about the idea that the human cell has got chromosomes in it. The chromosomes are basically just forms of condensed double helix DNA. You'll notice here from the picture that you've got A's and T's, C's and G's. Those are your nucleotides. We talked about those in 7th grade genetics, but something to think of. All right, sorry about that. I had to dismiss the last class. Okay, so the basics. Everyone should have their C5 worksheet. We're going to look at the first box here. The first box does ask us to address the idea of DNA and the idea that DNA, what is it, how is it used? I'd like just to kind of discuss some things here before I have you start doing some drawing. Generally, I'd like to remind everyone that DNA is found in the nucleus of every cell, and therefore a lot of its processes occur in the cell. The DNA, we always think of it as the double helix, this ladder with all these rungs on it that have been spun and twisted. It twists on itself numerous times to form the familiar chromosomes, which just makes it easier to store in the nucleus. But I want to talk about what DNA is used for, because clearly it's an instruction, but it's an instruction for making proteins, and so that's a rather important key thing here. So in the first box that you have, would you be kind enough to go ahead and draw this image? So we've got a generalized DNA strand here, very simple. I've gone and highlighted a portion of the DNA strand, and I'm referring to this portion as a gene. And I want to remind people that the rules for DNA are that the A's for adenine will always match up with T's or thymine. The C's for cytosine will always match up with the G's for guanine. And so every rung on your ladder here is either going to be an A and a T and or a C and a G, providing there's no mutations. So if you go ahead and start your drawings here of your DNA strand, make sure you indicate the gene section. And then we'll always talk about genotypes and phenotypes, but the gene here, we're going to refer to that in its physical standpoint. It's phenotype, it's physical trait, something that we see. So maybe this gene here is the code for blue eyes and brown hair, whatever it may be. That's the physical trait. The gene would be the combination of A's, T's, C's, and G's. Whatever the code is, that's your gene, your genotype. And the phenotype, well, this physical trait comes in the physical form of a protein. So some of you are going to remember that proteins are made up of 100 or more amino acids, and these proteins are produced in the cytoplasm and are very near the RER, which is the rough ER. So if you need to pause this scene for a second while you're getting the images, that's fine. Ask the teacher to pause. And here we are, back again. All right, so obviously everyone's got their drawings done. Well done. We'll get out of here. Alrighty. Now, to assist us with this view, we're going to go and bring up a little video here to help you. Alright, so my suspicion is here that what I'm going to suggest you folks do here is we're going to have the PowerPoint available on my screen in the background. To click on this YouTube video, which I'll actually show you is right here in the Google Chrome. If you can just click on this one and start it over again. I'd like you to watch this 4-minute video clip, and then we'll go on to the next thing. Alright, pause this YouTube video and then bring this back. Okay, so here we are, we're back at this screen. Let's go to the next box on our worksheet here, which is DNA replication. So, how do organisms pass on their genetic messages and their material? They do this through DNA replication, and it basically is very simply an opportunity for the DNA strand to separate into 2 single strands, and then from those single strands build duplicate copies of the other. As you can see in this image here, we're going from a single strand separating into 2 identical strands. These strands will be identical because they're both based upon the original strand, knowing full well that there's only A's, T's, C's, and G's. So, in your drawing, under your picture there on your worksheet, would you be kind enough to go and just simply draw this picture here? We've got a simple DNA strand that's breaking apart, the rules of A's and T's, C's and G's, and that this occurs in the nucleus. Go ahead, take a moment and draw this. Could somebody please pause the YouTube video? Alright, so YouTube video is back rolling again. Where does this occur? Please remember this occurs in the nucleus. So I'm going to ask the teacher or the student who's running the screen right now to go and basically, I know it's kind of hard to see it here, but on the Google Chrome, there's one here called DNA Wrapping and Replication. I'd like you to click on that video, start it over again, so I'll bring it back here for you. And to watch this video, if you'd be kind enough. Alright, so that's another 3-minute video. Go ahead and watch it. Alrighty. So, now that you've had a chance to watch that video, we're one step away from the early foundations of evolution discussion, and that being that during DNA replication, where the DNA is copied, there are opportunities and chances where a mistake can happen. And so that's just simply referred to as a mutation. So if the strand gets copied wrong, the variations and the different outcomes, all that comes from a mutation. You'll notice here Professor Xavier's classic phrase that mutation took us from single-celled organisms to being the dominant form of reproductive life on this planet. Infinite forms of variation with each generation, all through mutation. This process is generally quite slow and takes thousands and thousands and millions of years, but sometimes things do jump or opportunities do arise. And so what I'd like you to draw for your third box on your worksheet of C5 worksheet here is this image, which is of a DNA strand that appears to be normal, 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 error, normal, normal, normal. I would copy this as best of your ability. And then you're going to notice here that I've given you 3 main components that are considered catalysts for creating or helping mutations to occur. The first being the environment. That includes radiation, and in particular UV, microwaves and gamma waves, and all that kind of radiation for sure are dangerous to your DNA strands. You can get some errors occurring with that. Chemicals. Oh man, all you students who love to write with your Sharpies all over your body. God bless you, but chemicals in the bloodstream do not usually always bode well. So keep in mind with certain chemicals in your body. I also think of things like DEET and so forth. They can disrupt neurotransmitters as well as DNA strands. And some sound can actually go and cause your DNA strand to change a little bit. But those are the main ones for this area. Age. As you get older, your systems for DNA replication don't work as well and can break down and have problems. So age is a factor for mutations. They do find that on average, for everyone who's passed away from normal causes, that individual usually characteristically will have some forms of either cancer or fatty tissue deposits or things of that nature, which are basically directly caused by